So here I am on a crisp Saturday morning, like a madman, on a bridge over Wheeling Creek with a selfie stick to bring you a math problem. Now you might not know this, but way down at Elm Grove, there is a government geological probe that tells you how deep the creek is at that point. At any time, you can go online and see how deep it is at any time of day. And I've talked to a couple of people who've gone down the creek in either an inner tube or in a kayak. They get in at Elm Grove and they ride the creek down to Kroger, and they say that the length of the ride is a function of how deep the creek is. If it's really deep, then like it is today, then the water is flowing faster and the ride's going to not take a long time. But if it's really shallow and the water's just kind of creeping along, you're in for a pretty long ride. Now the question is, suppose that when the creek is 20 inches deep at Elm Grove, that the ride from Elm Grove to Kroger takes 4 hours. Suppose further that on a day like today, if the creek is running about 5 feet deep, then you can make that same trip in half an hour, 30 minutes. Suppose lastly that the relationship between the depth of the creek at Elm Grove and the ride time is linear, so that every drop of depth corresponds to a certain change in the length of time that the trip is going to take. Suppose it varies linearly. So we have 20 inches corresponds to 4 hours and 5 feet corresponds to half an hour. If that's the case, I have two questions. If the creek is 36 inches deep, how long will the ride take? And the second question is, if you want a ride that's going to take you 2 hours, how deep does the creek have to be in order to get you from Elm Grove to Kroger in that 2 hours? So sit down and take your 2 points, work it out, find the slope, tell me what the slope means in the context of the problem, and give me the equation that relates the depth to the ride time. Alright, that's it. Thanks for watching. Good luck.